At the beginning of this conference today, I mentioned how excited the team of Pasqal is to bring here on stage some of their most prominent customers. So far, we've had mostly leaders of the pharmaceutical industry. During the next panel discussion, we'll hear about how companies across multiple other industries who work closely with Pasqal are already using or preparing to use quantum computing. And for that, I'd like, ladies and gentlemen, to welcome on stage Elvira Shishenina, quantum computing lead at BMW. Please also welcome Frederic Barbaresco, quantum algorithms and computing segment leader at Thales Group. Please welcome Jean-François Bobier, partner and director Deep Tech at BCG. And finally, Krisztian Benyo, technical business developer from Pasqal, who will moderate this session. Thank you so much to the four of you. Krisztian, you're in charge.
Thank you very much. It's such a pleasure to hold this roundtable discussion with all three of you. So I wanted to kickstart this discussion by highlighting our many different collaborations that we are carrying out together. So first of all, I turn our attention to Elvira. Please, could you tell us a little bit more about how Pasqal and BMW Group has been collaborated in the past?
Thanks so much, Krisztian, and thank you so much for the invitation to this amazing event. It's quite already a long-term relationships, I would say, with Pasqal that they had. It started in 2021 when BMW first announced the Global Quantum Computing Challenge by publishing some of the challenging use cases for the ecosystem, and Pasqal responded to one of them, and they were quite clear winner of the case. And right now we are expanding our relations towards a more, let's say, complex types of collaborations with more complex use cases and challenges to solve. So yeah, very happy, can't say anything bad about that.
Thank you. And a quick follow-up question for you. I know that it's close to your heart. We recently signed a research collaboration together with ANSYS. So would you mind telling us a couple of words about this very, very new initiative between us?
Oh yes, happily. And that's what I meant under the more complex collaborations. I think it's a first example, that when the big industrial groups collaborate together with a quantum provider to tackle the complex multiphysics simulations in order to simulate the aerodynamics crash and other properties that could impact the design and shape of future cars. And here we are not only profiting or exploring the expertise of quantum hardware and software coming from Pasqal and end users' insights coming from BMW, but also the experience or expertise of coming from the small prototypes to large-scale industrial solutions coming from ANSYS. I don't know what to say. I mean, it takes a village to raise a child. It's a very, very old proverb, and I think this collaboration clearly illustrates it well. We need to put our efforts in order to nudge the very fundamental quantum computing research into the practical sense, and only by bringing together all those expertise, we will be able to leverage the complexity of this technology.
Correct, exactly. Thank you for that. So now I turn our attention to Frederic. So in the aeronautics and aerospace industry, Pasqal has been active with various collaborators. One of our oldest, especially in the space segment, is Thales Group, who has been quite active in the quantum field. So would you mind telling us a little bit about our collaboration together?
Thank you, Pasqal, for this event. This collaboration has started for more than 3 years ago in the framework of PAC Quantique Île-de-France. And we have decided to launch a collaboration with Pasqal because we have considered at this period that it was a mature technology. And we have identified with our business line on Thales Alenia Space, which is a joint company between Thales and Leonardo in Italy, on Thales in France, to address the problem of mission planning of constellation of satellites. So why is this problem? Because we have to scale up our classical algorithm to address these new problems, and we were convinced that it will be not possible to scale up our classical algorithm for the new complexity of the problem. And so we have started this collaboration on also a good idea of how to model this problem in terms of graph and to solve the problem with the Pasqal computer. In parallel, Thales was also involved in a project by European Space Agency, where with Rolish we have defined what are the use case for space application. And one of the four main use case for space, this one of mission planning of constellation satellite was selected. So it's important, and we are convinced that we could go further together in the space segment, because we consider that the space segment is ready and mature for quantum computing. There is many initiatives by European Space Agency or CNES in France. So I remember last year or 1 year and a half, we have organized a seminar at Thales Alenia Space in Toulouse with French MOD and CNES, and we have invited Pasqal to present their technology and our collaboration.
Thank you. Yes, as you can see, there are many different exciting use cases that are arising in various fields. So now I would like to turn our attention to Jean-François to share a little bit about what his vision is on new emerging use cases on which quantum may have an added value more in the short term than in the long term.
So thank you. So long term, we believe that there is a significant value with quantum computing. We published a report and we're going to make an update very soon. But we think it's going to generate around 450 to $850 million of value in the world. So if I put it into perspective, it would be an added 1% GDP. So it's a massive boost. And so now the question is, what are the short-term applications? So we need to be aware that, of course, today, we still don't have what we call the quantum advantage, so the time where we'll have a positive ROI for corporates, but that time is coming very soon. And there are a few applications that we are looking very closely that could be candidates. So the first is around, and I will go back to Richard Feynman. So he proposed, I mean, he was one of a community that sponsored quantum computing. He knew a lot about computing because he was leading actually the group in Los Alamos for the atom bomb to compute the critical mass of a bomb. And he knew how difficult it was with the means he had at the time. And he proposed quantum computing to simulate nature. First, it was really the first use case he was looking for. And then, of course, later we realized that also we could solve very complex mathematical problems. Shor was a second milestone, I would say, when he came up with this possibility to factor prime in a polynomial time. And so, going back to Feynman, I think that the first use case we might see might be around drug discovery, we just talked about it, material science, chemical science, because this is where we can map more easily problems that are useful today. And we don't need exact results. We can use heuristical methods. So that's really the area that we believe could bring advantage in the short term. And another area that we like is, and I think George talks about this very often, he says that we could power a Pasqal computer with the equivalent of an air dryer. Think about this a minute. A few air dryers. George is correcting me. Anyway, with your kitchen, and there are probably areas where we could also replace some workloads for the same effect, but with less, energy consumption. And that's the second area that I think is quite promising.
Thank you very much for sharing your thoughts. So back to you, Elvira. I think you've been trailblazing in quantum computing field for quite a while now. believe it or not, we have met more than 3 years ago as one of my first quantum hackathons back with Quantix. And so, based on your experience, what kind of use cases you have noticed that in recent years have significantly developed? And maybe second question is, what do you think is missing currently? What would you think the main element that we still need within quantum computing?
Very good question. Thank you so much. So I think many of us are traveling from different conferences around the quantum technologies. So we all have those examples in mind. BCG made quite cool reports, like yearly annual ones that also cite some of them with some predictions on the potential. So of course, the best what we can do is to solve the quantum native cases, such as, for example, simulation of quantum systems or for materials research. This is where we can expect this advantage certainly, most certainly. And this is where we have more or less clear ideas how to implement the solutions. After all, speaking about the quantum advantage in a more fundamental theoretical sense and speaking about the quantum advantage in the business sense, right, is not the same thing. So even if you're able to simulate molecular systems, and it was discussed actually today that probably not any HPC in the world will be able to compute classically, it's still small enough to, for example, bring the business relevance to the activities of BMW, speaking about the batteries or speaking about the hydrogen fuel cells and any other activities and materials. So how to scale up from those small systems to the bigger ones, I think this is a question not only of software development and bringing all together like best of a classical AI and quantum and many other computational paradigms, but also the scaling capacities of the hardware, and Lloyd today presented it quite well. So we can see some light in the end of the tunnel. So yes, I mean, chemistry, materials, research, finance, you will hear many of them today, optimization, even complex multiphysics simulation. The only thing I probably will tell in the end is that probably it's not the best strategy to nudge, let's say, the quantum computing and quantum simulations to something which is not quantum native and then get frustrated that you don't expect or you don't get that much big advantage. So maybe something good what we can do, at least on our side, to profit the time when the hardware will be fully available and fully performant is to figure out how we can reformulate our problems, go back to the physics of the processes, find some new insights that will help us to present them in a little bit more quantum way. Or, for example, discover some new challenges that, for instance, because of our very narrowed classical view, we don't really see right now, but which could make total sense while the quantum technology will be available. So a lot of work to do. And again, with the same thesis, let's get together and do the job.
Thank you very much. Indeed, you're very correct. So taking this angle of new challenges to the extreme, let's look a little bit more towards the vast infiniteness of space. So back to you, Frederic. I believe you have recently contributed to the JIFAS report for the French aerospace agency sector. So could you share us a little bit about the recommendations and the conclusions you have made to this report?
Thank you. Yes, so GFAS. So GFAS is a group of industry for space and aerospace. And we have made a report on quantum technology. So not only a quantum computer, but also a quantum sensor and quantum telecommunication. I was involved with Alain Refloc from Onera to define the chapter on quantum computing. So for the time being, we cannot divulgate the recommendation because we have just provided the report to the GFAS COMEX. So, but it will be soon available on with a public recommendation. But mainly the sector of aerospace is very interested by quantum computing, and what is also important for this sector is to benchmark the performances. So Thales is leading with CEA on Eviden on CNRS, a program which is called BAC for application-oriented benchmark of quantum computing. On the request of GFAS is try to orient also benchmarking for aerospace application. It will be important for the structuration of the market segment.
Yes, sounds very interesting. Please do keep us updated when the report has been released. And talking about these unreleased reports, I believe you also already mentioned, Jean-François, that with BCG you are working on an updated version of your initially released quantum report and forecast. So would you mind, without spoiling too much, sharing a little bit about your vision of how especially the ecosystem or the whole field of quantum computing has evolved, and where do you think it is headed, especially given the recent advances in quantum error correction in particular?
So let's start with the good news. I mean, quantum performance has been doubling every 1 or 2 years, and we still have a long-term I mean, for the next 5 years, and thanks to Loic, we have more confidence that will continue to improve, which is important. Doubling every 2 years is quite important. It means a feat, you could say. Basically, be able to catch up with Moore's law in a way for quantum. There are some bad news, however. NISQ was supposed to deliver value. It turned out that the value is not there, and there are a lot of reasons for, but let's make it simple. The fidelities have not improved enough, and therefore the circuit depth we can explore is very limited. The good news is Pascal is not necessarily touched by this disappointment about NISQ, because you have the analog approach, which is not concerned by those problems in the circuit depth. And then, of course, we have a prospect of error correction. And the very nice news is that it's coming much sooner than we thought. When we published our report 4 years ago, it was a prospect that we were hoping to have after 2030. And Loic mentioned it, we could have it by 2028, which is very good news. And actually, the good news is that there are a lot more use cases with error-corrected computers. Already 90% of the value that we forecast was for error correction anyway. So it's good news, I think.
Yes, absolutely. We are indeed off to some very exciting coming years. So we have reached the end of the time for this discussion. So I would like to ask you, are there any final messages that you would like to share with our public?
So as any emergent technology, it needs time to get mature. So I just ask everyone to be patient and to not stress our dearest quantum hardware providers and software providers, so that we can take their time and develop the tools, the features, and present them properly and transparently to the end users, such as us, BMW, Thales, and any other industrial companies. And also on our side, we try to do our best to provide all the possible support and insights to the young companies, especially to the European players, in order to progress fast and at the best scale possible. Yeah.
Just to say that Thales has a very large footprint because we are in 67 countries. Many of our customers are requested Thales to explore quantum computing. So we have many opportunity to push Pasqal technology in this country, and we have started for some of them. And we want to be an early adopter of this technology for our market, and so we will push and try to use your technology and to prove to our customers that we are ready to use it as soon as possible.
So very quickly, I think it's a technology that is moving very fast at an exponential rate, actually. So exponentials are, we saw it with COVID, it starts from nothing and then it can be very big. So we really recommend every people on the room to get prepared for it. It will come faster than we think. And that's all I had to say. Thank you for inviting me.
Thank you very much for sharing your thoughts. And once again, Elvira, Frederic, and Jean-François, it was a pleasure.
Thanks, Krisztian.
Thank you.